So 1 mole of any gas occupies the same volume. It's for this reason that we can compare volumes of gases by using the balanced chemical equation. So for this example, we've been given a balanced equation for propane gas being burned in oxygen, and the balanced chemical equation and the coefficients that are in the balanced equation tells us the proportions of things that react. So what we're able to say is that 1 mole of propane reacts with 5 moles of oxygen to produce 3 moles of carbon dioxide and 4 moles of water. And the question states or asks us to work out what volume of carbon dioxide is produced, so carbon dioxide, when 100 cubic centimetres of propane gas is burned in excess oxygen. So these are the two species that we're concerned with. So our propane and our carbon dioxide react in a 1:3 ratio. And if we're told that 100 cubic centimetres of propane gas reacts, then we can then work out that the volume of carbon dioxide that's produced must be 300 cubic centimetres, and that's just using this ratio here, 1:3. So example 2 here is slightly different. Here we have different gases reacting, and we're producing a gas as well, and we've been given some quantities in the question here, and we're asked for the volume and composition of the resulting gas mixture. So again, we're using the coefficients in the equation and the molar ratio to work this out. So what we can say first of all, again our ratio is 1, 5, 3 and 4. Water can be discounted because it's a liquid and we're only concerned with gases in this equation. So what we can say first of all, we've got our propane and our oxygen are our two reactants. We need to work out which one is in excess and which one is the limiting reagent first of all. So we have in the question here 10 cubic centimetres of propane gas is mixed. So if we take that 10 cubic centimetres, now for 10 cubic centimetres we're going to produce 50 cubic centimetres of oxygen, and we're told in the question that we've got 75, so we have enough there. So that's what we've done in that case. If we go back the way and take this 75 cubic centimetres of oxygen, so if we start with 75 of oxygen, how much propane do we need? So if we divide that by 5, and that gives us 15. However, we don't have 15 cubic centimetres, we only have 10. Therefore, propane is our limiting reagent and oxygen is in excess. So what we can then say is that 10 cubic centimetres of our propane all reacts, so that's gone. We start with 75 of our oxygen, but only 50 is used up. Okay, so we have 25 left over at the end of the reaction. What we then need to work out also is our volume of carbon dioxide. So if we take our limiting reagent, our propane, compare that to our carbon dioxide, so they react in a 1:3 ratio. So if we start with 10 cubic centimetres of propane, then we'll end up with 30 cubic centimetres of carbon dioxide. So our resulting gas mixture is made up of 25 cubic centimetres of oxygen and 30 cubic centimetres of carbon dioxide.